This lecture is on finding volumes of pyramids and cones. So back to our formula table. The formulas for volume of pyramids and cones are just 1/3 of the corresponding ones for prisms and cylinders. To derive this, you have to know something about a calculus of solids of known cross sections. So I'm not going to go there. Suffice it to say, to get a pyramid, it's 1/3 times the base area times the height of the pyramid. And then for a cone, since the base is a circle, it's 1/3 times pi r squared times the height. Now, again, we have to be clear about what constitutes as height for a pyramid. So going back over to this drawing, in blue here is the slant height, and that is useful for lateral area, surface area. The green are the lateral edges, doesn't do much for us. The red, that's what we're interested in. That's what we need. And for a cone, it'd be the same thing. You don't want the distance along the outside. For a cone, you want the distance right down the middle, makes a right angle here. Assuming it's a right cone, right pyramid. And again, I put in these little Pythagorean connectors, I call them, because sometimes you've got to use the Pythagorean theorem to relate these different lengths to each other. So we're going to do some sample problems with this. Okay, we'll start with some pyramids, then go on to some cones, back to some pyramids. All right, so volume is 1/3 base area times height, which is 1/3. Now the base looks like it's 54 by 54, so that's 54 squared. And then the height, that's a little bit more challenging to find because we know a slant height but not an actual height. So the way to find that is we'll draw into the middle. This is a right angle. Half of 54 is going to be 27. That's the height. So it's h squared plus 27 squared is 45 squared. The perspective's a little hard to see. We solve that equation for h, and then we plug in h right there. And that's going to give us our volume in centimeters cubed. So you need to solve this Pythagorean equation, and then when you find out what h is, 1/3 54 squared times h. This one's perhaps a little bit easier to see. So it's 1/3 base area times height. Let's draw in the height. Again, it doesn't appear there. If it's 10 across, that makes this 5. So it's 5 squared plus h squared is 13 squared. Make sure you're clear which is the hypotenuse. It's going to be the slant height, the 13. This ends up being 12. So we have 1/3. The base is 100 because it's 10 by 10. It's a square times 12. And so overall, that's 400 inches cubed. Okay, another pyramid. This is an oblique pyramid. Distance from the top to the bottom makes a right angle is the height. It's not going to be this angle distance. So our height is 18. They give us the base. It's 8. So the volume is simply 1/3 base area times height, which will equal 48 centimeters cubed. All right, we'll take a look at a couple cones. Go back to one more pyramid. All right, over here we have 1/3 pi r squared times height. So 1/3 times pi. The radius is going to be 5 because it's half a 10, so 5 squared. The height's 24, and this will be in centimeters cubed. So all that goes into a calculator. For number 11, this time we have a slant height, which would help us for lateral area, but we need to have a radius and a height. So we look at this right triangle here, and if this is your radius, it is. You do r squared plus 15 squared is equal to 17 squared. That's going to turn out to be 8. That's a Pythagorean triple. So the volume is 1/3 pi times radius squared, so 8 squared times the height of 15, and that's in meters cubed. So again, you need a calculator to do that. And then over here we have an oblique cone, but no problem because we have the height. It's 1/3. The radius is half the diameter, so that's 3. So 1/3 pi times 3 squared times a height of 2, and that'll be in feet cubed. And lastly, let's take a look at another type of pyramid. This is a pentagonal pyramid. It's got an apothem of the base of 5 centimeters and a height of 10. So we know the height. The height is 10. We're good there. We have to get the base. So I look at a top view of the base, and this is 5. Now in this pentagon, there's 10 of these, so 360 over 10 makes this 36 degrees. I need to get that distance. Compared to 36, that's an opposite. This is an adjacent. Opposite over adjacent's tangent. So tan 36 is x over 5. So x is 5 times tan 36. So to get this one triangle, it's a half times the base, which is 5 tan 36 of that triangle, times the height, which is 5. So half times the base times the height. And there are 12 of those triangles, no, excuse me, not 12, 10 of those triangles in the entire pentagon because there's 2 per side. So right here is what my base is going to be. So what you do is you take all of this, which is your base, and you multiply it by your height, 10, and that will be in centimeters cubed.